the first one we had the stack of 8 cue cards, and the first 3 were the most important. Just before the speech, drops all the cards and picks them up in random order. So that was the rules to top and bottom, right? 3 cards. We had 8. And then after the word probability affects just the top. So it says, what is the probability? The cards 1, 2, and 3 are still in order at the top of the stack. So we knew that on the top, we'd have 1, 2, 3. So we'd have, this one would have to be 1, this one would have to be 2, this would have to be 3. So those are only choices. And then on the bottom, we would have 8, 7, 6. And what did that reduce to? 1 over something. I can't remember what this is. What's 8 times 7 times 6? 8 times 7 times 6? 336? Is that what you said? Oh, I only heard the 36 part, and I was like, has to be much larger. That makes sense. Okay. Number 2. A gardener has 11 identical looking tulip bulbs. What does 11 identical mean? They look the same. I could have 11 factorial possibly on the bottom because you can't tell the difference between the bulbs. Correct? 11 identical looking tulip bulbs, of which 6 will produce yellow tulips and 5 will become pink. Okay? That's top and bottom. We have 11, 5 yellow, that's a lie, 6 yellow, and 5 pink. She randomly selects and plants 6 of them and gives the rest away. Still top and bottom, correct? Because I haven't gotten to the word probability. All that affects the top and the bottom. Then it says, when the flowers start to bloom, what is the probability that of them all being yellow? All yellow. Okay? So we have to have all yellow on the top. How do we do that? Do these yellow have any specific orders or anything to them? No. Are we planting them in a row and we have to, like, the first one has to be yellow, last one has to be whatever? Is there anything like that? Any order to these yellows? No. So how can we get all yellows? 6 yellows, and we choose all 6 of them. We agree? On the bottom, what could we do? How many are there? Remember, bottom's total, no restrictions. What would we do? 11. How many are we choosing? 6. So bottom's total, no restrictions. So it'd be 1 over 462. The next one is a test. It consists of 7 true and false questions. What happens when we have true and false questions or multiple choice questions? We draw lines for each question, correct? A student who forgot to study guesses randomly on every question. What is the probability the student answers the first 4 questions correctly? So this only affects the top, first 4 questions correctly. So we have 7 questions. 1, 2, 3, 4, 5, 6, 7. We have 7 blanks on the top. We have 1, 2, 3, 4, 5, 6, 7 on the bottom. Correct? It's a good thing about these. If you have blanks on the top, you're going to have the same amount on the bottom. Now, what is the probability the answers the first 4 questions correctly? What does that mean? That only affects the top. Yeah. R. So how many options? 1. 1, 1, 1. I don't know what they are, but I do know that they're correct, so I have 1 option. Correct? Now, how many do I have left for the last 3? 2, because it's true or false. So that's 8 over. The bottom is total, no restrictions. So what happens to the bottom ones? They're all just, how many options do I have for each blank? Yeah, 2. So it's 2 to the power of what? 7. One out of 16. Number 4 says a meeting takes place between a diplomat, so there's one diplomat, and then 17 government officials. So there's a dude there and 17 government officials. However, 10 of the officials are spies. So how many are not spies? 7 are not spies. I'm going to write this up here. If the diplomat gives secret information to 8 of the attendees, so 8 are how many we're choosing, correct? Top and bottom, we're going to choose 8. Whatever comes after probability affects only the top, though, right? What is the probability the diplomat gives secret information to exactly 5 spies? So exactly 5 spies. How many people is he giving information to in total? How many people is he giving information to? If the diplomat gives secret information to how many? 8, correct? So on the top, I'm going to have to choose 8. On the bottom, I'm going to have to choose 8. We agree? On the top, they gave us a restriction. They said there has to be exactly 5 spies. So on the top, there has to be 5 spies. But what's my problem? How many do I need on the top? 8. So I need 5 spies and 3 what? Not spies. If I'm choosing spies from spies and not spies from not spies, is it a perm or a com? When you do principals from principals, students from students, boys from boys, girls from girls, adults from adults, kids from kids, spies from spies, what do we use? C. Is there any difference? Is there any order to them? Do they have jobs as a spy? Does the jobs have spies and the not jobs have spies? No, it's spies from spies, not spies from not spies. Whenever you're choosing from the same group, it's a C. Adults from adults, kids from kids, principals from principals, students from students, defense from defense, forwards from forwards. Spies from spies, not spies from not spies. You will use C every single time. Okay? How many spies do I have to choose from? How many of them are spies? 10. And I'm choosing 5. And means I multiply. How many are not spies? 7. And I'm choosing 3. Bottom is total, no restrictions. How many total are there? How many total are there? 17. And I'm choosing how many? 8. Everyone type it in, see if you get the right answer. Make sure you put the top in. Oh, it doesn't matter. Brackets. In this case, it doesn't matter, but it's good to practice. The nearest hundredth, I get 0.36. Make sure you're getting that. What if it said 2%? What if it said to the nearest whole percent? What would I do? Take that answer and times it by 100. And I get 30 or 36%. Which one's correct? If it says if it just says, what's the probability to the nearest hundredth? Probability to the nearest hundredth. You'd give 0.36. Okay? because there's no word percent in that. If I said probability to the nearest hundredth, you'd go 0.36. If I said probability to the nearest percent, you have to take your answer times by 100 and give the percent. They can ask it either way. You have to read. Okay? Number 5. Sarah is carrying 6 pages of math homework and 4 pages of English homework. A gust of wind blows the pages out of his hands. I guess Sarah's a he. And he is only able to recover 7 random pages. Okay? Flew away 7 random pages. Are we ordering these pages? Does the math pages and English pages and the order, does it matter? Does it say it's ordered? No. So this is a permutation or a combination. It's a combination. So there are 6 math. There are 4 English, which means there are 10 pages total. A gust of wind blows the pages out of his hands, and he only recovers 7. So every case is going to have how many pages? 7. How many cases was in the previous one? 8. This one is 7, right? So we have to pick 7. Now, whatever comes after the word probability affects the top. What is the probability he recovers at least 5 pages of math? At least 5 pages of math. So say I gave that to you as a question in probability or in Perms and Comms. At least 5 pages of math means 5 pages or more. So we would need 5 math and how many pages are we recovering? 7. 5 math and 2 English, or 6 math and 1 English, or 7 math and 0 English. Is this one even possible? How many math sheets are there? 6. That case can't even exist. Right? Because there are 6 there. So I always draw it and then cross it off to make a point that, yes, there is a 7th case, but we can't have it because there's only 6 math. Okay? So how would we do this? Math from math, English from English. If I take math from math, English from English, it's C. Parents from parents, students from students, principals from principals, spies from spies, not spies from not spies. C, C, C. Every single time you're choosing from that exact same group, it's a C. You don't even have to think. I'm going math pages from math pages. It's a C. Unless we were ordering the math pages within the math pages, which I hope they don't do, ever, but they could. So there's no order to this, so it's a C. So we go math. There are 6. We choose 5, and means we multiply. English, there are 4. We choose 2, or means plus sign. There are 6. We choose 6 times 4. We choose 1. And my numerator is going to be in brackets. Divided by total, no restrictions. How many are there total? 10, and I'm going to choose how many sheets? 7. Everyone's typing it in to see if they get it right, because some people will have the work right and get every question wrong on their test because they've never typed it in. Which is a sad day. Very sad day. I get 0, 1/3 or 0.33333333. If I said to the nearest 1/10 of a percent, what would we do? What if I said nearest 1/10 of a percent? You'd go the 0.3333 and you times it by 100 and then give me to the nearest 1/10. So if I asked for 1/10 of a percent, we would do 33.3%. Number 6 is a card question. Card questions are often combinations, correct? They're pulling aces from aces, hearts from hearts, blah, 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 right? So here we have, given a standard deck of 52 cards and randomly drawing 5 cards from the deck. So we have 52 total. We're drawing 5 cards. Every single time the case can be 5, 5, 5, 5, 5, right? After the word probability only affects the top. So it says, determine the probability of getting exactly 1 ace. So actually, after the word probability is just like doing a perms and comps question, correct? And it'll just go on the top. That's all it is. So exactly 1 ace. So if I gave you that before, exactly 1 ace, that would mean 1 ace and what? 4 others. So how the heck would we do that? How do I get aces? Choose them from? Yep. How many aces are there? 4. So we do 4, choose 1, and others. So all I do for others is I take 52 and I subtract off this first number, right? 52 minus 4 is 48. Choose 4. That would be how I would do this question if it was a perms and comps question, correct? After the word probability, just treat it like it's a perm and comp question. Then at the end, you just divide by total, no restrictions. How many are there total? 52. And how many am I choosing at a time? 5. Yeah, that's it. 52C5. So I want you to type it in and give it to me this way, and then I want you to give it to me as 1/10 of a percent. Practicing it. So when I typed it in, I got 0.2994 blah blah blah. And if I want to nearest 1/10 of a percent, I take that answer, I times it by what? 100 every time. And now I get 29.9473. I'm to the nearest 1/10 of a percent. So I'm going to go 29.9. 1/10 has 1 0, so the nearest 1/10 is 1 decimal place. 29.9%. Okay, I have the word awesomeness. The first thing I'm going to do when I get a word, AWESOMENESS. Okay? After the word probability is just like a perms and comps question. That's what I'm going to do. I'm going to do the perms and comps question. That will give me the top. Correct? Every single time. After the probability is just a perms and comps question. So we're going to go determine the probability. The word starts with a vowel, ends with a consonant. Okay. Good stuff. I'm going to do my perms and comps question on the top. So I'm going to have, give myself no room. On the top, I'm going to do, starts with a vowel. How many letters are in awesomeness? 11, it looks like. Why did I make a fraction? On the bottom, what has to happen? 3 factorial, 3 factorial, because the letters doubling or tripling here. Start with a vowel. How many vowels are there? A, E, and O. 5. End with a consonant. How many consonants are there? 6. How many letters have I used up? 2, right? So how many do I have left for this blank? 9, 8, 7, 6, 5, 4, 3, 2, 1 times 6. I'm going to figure that out right now. I'm going to type that into my calculator. Everyone type that one in so you get a number. 5 times 6 times 9 factorial. Make sure you divide by 3 factorial in brackets. 436. So there are 302,400 words from the word awesomeness that begin with a vowel and end with a consonant, right? And that would just be my top. We agree? The bottom is total no restrictions, right? How many letters are in awesomeness? 11 factorial over 3 factorial, 3 factorial. Total no restrictions. So any question I ask about awesomeness, the denominator is going to be 11 factorial divided by 3 factorial, 3 factorial. Okay? So I get 1,108,800. And I'm going to divide them. So I'm going to go 302,400 divided by. That reduces to 3 over 11, which might be what they asked for. Or it reduces to 0.27. Or if I ask for a tenth of a percent, I'm going to get I'm going to take my decimal and times it by 100. And so I'm going to get 27.3%. Because it would be 27.27, right? Which is 27.3. Now what if I do vowels together? Well, I treat the top just like vowels together question, right? Vowels together question, this would be my top. You go 3 factorial, 3 factorial. Vowels together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 5 vowels. I'm going to hook them together. I have 5, then 4, then 3, then 2, then 1. And then how many letters do I have left? 6, 5, 4, 3, 2, 1. And then what do I have to times by? 7 to have them together, correct? Because they can move. So we're just doing a probability question, or we're just doing a perms and comms question. That would be the top, correct? And the bottom is total no restrictions. The bottom of every single one of these probability, no matter what I ask about this awesomeness question, is total no restrictions. So I would have 11 factorial divided by 3 factorial, 3 factorial. So the bottom of this is going to be 1,108,800. Every single question, because it's total no restrictions. Yeah. On the top, we're going to get 5 factorial times, wrong spot. 5 factorial times 7 factorial divided by 36. $16,800. Which is 1 out of 66. Which is 0.02. Times it by 100. Is 1.5%. Do these make a little more sense now? Top is what's ever after the word probability. You treat it like a perms and comms question, correct? Bottom is total no restriction. We're going to practice a whole bunch more of these tomorrow. But right now I'm going to hand out, this is actually like a little daily quiz. So we're going to try this one out.